What's up, everybody? Today we finish up conditional probability and sort of kind of we finish up probability in general. We're back at the end of the probability packet in the middle of page 19 where we had left off from conditional probability part 1. And I'm looking in the middle of the page at number 3 just to kind of use it as a warm up. And we've seen a couple instances of finding probabilities from tables already. Got to give you guys a joke. This one I thought would be good to go bilingual on. So this is a joke in Spanish, and since I learned this joke in Spain they lisp the Z's and the C's. So the way they would say it is que hace el pez, que hace el pez. And if you know your Spanish, that means what does a fish do? Pez is the fish, right? So the answer is que hace el pez. The answer is nada. And that's a joke because nada means nothing. The fish does nothing, but also nadar is the verb to swim. So the fish swims. So I bet you if you told someone who spoke Spanish that joke, they would think it's pretty funny. Take it from me. Can you try number 3 if you haven't already on the middle of page 19? I took the liberty of just filling in some totals for the columns and the rows, but it's kind of funny in this one, A, B, and C. The questions don't have much to do with non-recycled items. So really, I just needed this number, 79.4 for this question, and then also my totals that are in the recycled column. So you'll see it was kind of a waste of time for me to put those numbers down the right. What's the probability? Let's use some notation here. A sample of recycled waste is paper. That is conditional. Given that the waste was recycled, what's the probability it's going to be paper? So probability of paper, given that it was a recycled item. The wording, it's just a little different here. Given that it's recycled means you're only pulling from the ones that are recycled out of the 79.4 millions of tons. Paper is paper and recycled gives you 45.2 up top. So that first probability is better seen as a decimal, about 0.569. Second one, what's the same deal but with plastic? So probability of the waste being plastic, given that it's a piece of recycled waste. So same denominator of 79.4. And the plastics that were recycled are just 2.1, just a measly 2.1 millions of tons. And then that can go into the calculator. You have a small chance of that, 0.026. Okay. Third one, same idea. Probability, given that it's recycled, that the waste is going to be glass. Recycled. So again, divided by 79.4, and glass and recycled gives you the 3.2. So a slightly higher, but still low chance, 0.040 to the nearest thousandth. There's a good question underneath, a school system. So we're given some percentages here. Number 4 says a school system compiled the following info from a survey it sent to people who are juniors in, high school 10 years earlier. 85% of the students graduated from high school. Of the students who graduated from high school, almost all of them are happy with their present jobs. 90% of them are happy. Given that they did not graduate from high school, you get a 60% chance of happiness. What's the probability that a person from the junior class 10 years ago graduated from high school and is happy with his present job? Let's think about it. Graduated and happy. And makes me think of multiplying. So I'm going to multiply the 0.85 chance that you graduated times the 0.9 chance of happiness given that you did graduate, right? 0.85 times 0.9 gives me 0.765. Graduated and happy is going to be multiply. What's the probability that a person from the junior class 10 years ago did not graduate and is happy with his present job? Well, did not graduate, if 85% did graduate, that means the remaining 0.15 did not graduate. And happy, 60% of the non-graduates are happy with their job. So I'll say this is going to be 0.6. Did not graduate and happy. Multiply those two. So 0.15 times 0.6 and you get 0.09. So less of a chance of that occurring. Now would be a great time to flip to the last page of the probability packet, virtual handshake to all who have gotten this far, and look at page 20, the last page. I would say under these problems labeled practice, pause the video now, Try your best on 5, 6, 7, and 8. Take it as good review of all of probability and see what you can come up with. All right, then let's join back in. I see two conditional probability exercises from tables, and it's going to ask me a utility company asks 50 of its customers whether to pay their bills online or by mail. What's the probability a customer pays a bill online? So I'll say online, given that the customer is male. If it helps, make your totals first. Really, we need, given that there are males, we need the total of males, which is 20 males, 12 plus 8. So out of those 20, what's the probability you're male and online? That's going to be 12 from the 20. So you would definitely reduce that. Make it 3/5 is a good probability. And I'd leave it as a lowest terms fraction. It says researchers ask shampoo users whether they apply. Okay, so this one's interesting. Directly to the head or using a hand. I had no clue that there are people out there that put the shampoo bottle on their head and put the shampoo directly on their head. I always squirt it into my hand first. Maybe that's just me. I feel like that's kind of like the common question. Have you heard this one? Are you the type of person when you're putting your shoes on, do you do sock, sock, and then shoe, shoe? So both your socks are on first and then both your shoes? Or do you do sock, shoe, sock, shoe? I think I do sock, sock, shoe, shoe, but I'll have to get back to you when I actually test myself out when I'm not really thinking about it. So apparently there are people in this world who take the shampoo bottle and put the shampoo directly on their head. So we're just going to go with it. And whatever totals we need, we'll get them from the table. What's the probability that a respondent applies shampoo directly to head? So I'll just say head for that, given that that's a female. Like that. Okay, so out of just the females, the 24 plus 6, we could add those up to get 30 females total. How many of them are applying directly to their head? That is 6 out of those 30, or 1/5, which is a higher probability than I would have expected. All right, number 7, suppose you pick cards from a standard deck, find the probabilities, and assume events occur in order. Keep this in mind. When I can, I'll try to put the word then to indicate order, so like in B, face card, then ace. But if it's not there, it implies you get the face card first and then the ace second. If I mean for the order to be either way, I will explicitly state that in the problem. So probability, you're picking cards from a standard deck, and what's the probability? I pick 2 random cards, and I get a 2, and then another 2. And it doesn't say with replacement, so you pick the card and it's gone. Well, let's do it, right? This is good multiplication rule practice. Probability of picking a 2 on the first card, there's 4 2s out of 52. Probability of picking a 2 on the second card, well, 1 is already gone, so there's 3 left over out of 51. Canceling helps, multiplying across, right? 3 over 6, 6, 3. Probability you get a face card and then an ace. Think of the face cards in the deck. We've seen this before. There are 12, the jack, queen, king of each of the 4 suits. Then an ace. Once you've picked a face card, it's gone, but ace isn't a face card. There's still 4 face cards to choose from. So if things cancel, that's great. So 4 goes into 52, we'll say 13 times. And actually 12 and 51 share a common factor of 3. 3 goes into 12 4 times and into 51 17 times. So lowest term fraction, you are getting 4 on top, 221 on the bottom. Black card, diamond. Okay, black card first. Think of, I guess out of 52, it's half the deck, or 26 of the cards. Diamond, once you pick that card, there's 51 cards left to choose from, and there's still 13 diamonds. Diamonds are not black. So you have 1 over 2, and you'll get 13, we'll say, out of 102. Okay, kind of just moving down these. Black and a diamond in either order. There's more cases here. Let's span this out. So probability you get black first, diamond second, or means add, right? I could get the diamond first and the black card second. Both of these probabilities are going to be the same. If you double one of them, you've got your answer here. So black cards out of the deck, we said that's half the deck, so 26 out of 52. Diamonds in the deck, actually we just did this one, right? 13 out of 51. Plus another one, right? Diamonds first, 13 out of 52 plus 26 out of 51. So I really should have just used what I did, the work that we did in part C. And that is 13 over 102, the answer I got for part D, plus another 13 out of 102. And that should give you, when all said and done, 13 out of 51 should be a good way to reduce that. Heart, red card. Okay, so heart first, then red card. So you pick one of the 13 out of 52 hearts. Then how many red cards are left over? Well, you've taken one of those red cards because hearts are red. So there were 26, but now there's only 25 out of 51. So you see examples where both the numerator and denominator get altered. 13 out of 52 is 1 and 4. And then we could say 25 over 204. All right, we are picking 3 cards, a 3, then a 4, then a 5, in that order, and it doesn't say there's any replacement. So 4 3s out of 52. How many 4s? Well, also 4 4s, but now out of 51 because we've picked a card. And then another 4 up top out of 50. Okay, reducing is always a good idea. I say that each time. So 4 goes into 52 13 times. Anything else reduce? You could cut these both in half. So 2 goes into 4 twice and 50 25 times. Anything else? I'm looking around. Well, you have 8 up top. You have the product of those 3 numbers on the bottom, 16575, to check your answer with that. And the birthday question. Okay, so I was born on July 12th. What's the probability that I picked 2 other random people and they were also born on July 12th? Be careful. I know this problem involves 3 people, right? But the probability I have my own birthday is going to be 100%. I was definitely born on July 12th. I have the birth certificate to prove it. Probability that random person number 1 matches my birthday, if we're not considering leap years, there's only 365 days in the year, and they have a 1 in 365 chance of matching my one day, July 12th, out of the 365 days in the year. That's for that second person. For the third person to match, they also have the same odds, a 1 in 365 chance. So a little bit more practice with multiplication rule. Even though 3 people are involved, this is going to be the same as 1 over 365 squared. And you get 1 over, I'll leave this as a fraction, 133,225. And last but certainly not least, let's just emphasize it. In general, if you just have 2 random people, what are the odds they have the same birthday? It's not 1 in 365 squared. The first person always definitely has their birthday. The second person just has to match them. So 1 in 365 on its own is going to answer that question for you. All right, keep up all the good work. I will see you soon.